Hey, Algebra, let's see, we are going over the homework for day 6. Our day 5 lesson was one where we're factoring, like this stuff, factoring some of these. Day 6 is where we start to work in some coefficients in front of this x squared term, and that ends up like revealing itself a couple different ways. I want you to see here, it's like, where does this 3 come from? Well, that's because all of these terms are divisible by 3. So that's something we should take care of in the beginning. We should pull a factor of 3 out of everything. We'd pull a 3 out from this. And what's 3x squared divided by 3? Well, we get an x squared. Divide that 12 by 3, we get a negative 4x. And divide 12 by 3, we would get another 4. Okay, so then we take that part, ignore the 3 for now, and factor that out for, what times what would be 4, but then add up, what is it? Multiply and add up to? A 2 times 2 would make 4, and a negative 2 times negative 2 would also multiply to make 4, and a negative 2 times plus a negative 2 would add up to a negative 4, and that's why we get this answer. I'm going to use that one, to help us go over a couple of these. So let's see. I am going to start right up here in the mild ones, but the ones that I'm really asking you to all do is this section, right? The section here, the medium ones. Just going to zoom in a bit. We will go over this, but skip ahead in the video. This is our learning target, is to be able to do these. Now these are all ones that are factored with the greatest common factor. What is the largest thing that you can divide out of both 12 and 18? So it's like, well, both are divisible by 2, but if I only divided this by 2, and I got 6x squared minus 9x, I look at this and go, 6 and 9 are also divisible by 3. I didn't pull out the greatest common factor, I just pulled out a common factor. So I still have to pull out a 3 from this. And so a 3, and what is 3 times 2? Well, that's 6. So that's actually our greatest common factor with this. The largest thing that I can divide out of both of these is a 6. But it doesn't stop there. I also look at the variables and go, this has 2 x's. This has 1 x. I can also pull an x and divide an x out of each one. Our answer for this is going to be, well, 6x. This is where you could use something like this, and you could say, okay, well, we need to get to 12x squared and a negative 18x, and our answer, one of our factors, is a 6x. Now, I'm not using this part of the table or this part. I'm really just interested in this. What would I multiply 6x by to get 12x squared? Well, I would need another x, and I would need a factor of 2. What would I multiply 6x by to get 18x? I don't need another x up here because I have an x, but 6 times negative 3 would make negative 18. And that's our answer, 2x minus 3. I could use this table for everything, but I actually want us to get in the habit of looking at these and saying, what can I pull out of each of these? It's like reverse distributive property. Each of these numbers, 5 and 15, what are they divisible by? 5. And this has a y, it has 2 y's, and this has 1 y. I can pull 1 y out of these. If I pull 1 y out of this first one, then I still have a y left over. And if I pull a y out of this one, I don't have any y's. So now I divide. Negative 5 divided by 5 would be negative 1. I could write that as negative y, that's okay. And 15 divided by 5 would be 3. Okay, now here's the thing. I could check this. If I do 5y times this, I get that. If I do 5y times 3, I get 15y. Our way of checking this is to redistribute, but this is called factoring. Look at this. I can pull a 10 and not just 1 x out of each one, but 2 x's from this and 2 x's from this. This one won't have any more x's, and 30 divided by 10 would be 3. Okay, so no x's. This one would still have an x left over, so I'm going to put that in there when I pull out 2 x's. And 20 divided by 10 is 2. Again, how could I check this? Multiply forward with that. Distribute. Okay, here. Both are divisible by 5. I can pull 1x and 1y from each of these. 1x and 1y. Now, when I divide that out, negative 10 divided by 5 is negative 2. And I need to get 2 x's and 1 y. I already have an x and a y, so I'm going to need another factor of x. when I look at this, I already have, look at that, it's the same identical thing. So when I divide this by itself, I get 1. And so we would need that. If we had 5x times something, I would need times 1 to get that part. So that 1 is very important. It doesn't turn to 0, it turns to a factor of 1. Okay, and this one right here, 18 and 27 are both divisible by 9, and I can take an x out of each one. 18 divided by 9 is 2. X times x would make x squared, so x times x would make x squared. And 9x, I can pull the x out, and 27 divided by 9 is 3, and that's our final answer for this one. Okay, so that's 5 minutes going over that. Remember, that's not our learning target. Our learning target is these types of problems down here. All of these are going to be problems where we have something, a binomial times another binomial, a binomial times another binomial. I'm just going to set this up all the way down, all the way down. Okay, they are going to be able to be factored out. Now, remember, as we've been doing in class, these should be a little bit easy. I want to say, what multiplies to 9 but adds to 6? Well, a pair of 3s. A 3 and a 3 would multiply to make positive 9 and add up to positive 6, and an x times an x would multiply to make x squared. These are both positives. That one should be pretty easy to do. This one right here, now we got a negative here, but this is positive. So, all right, x times x would make x squared. To get 15, I need two numbers that multiply to make 15. Well, that's either 15 times 1 or 5 times 3. However, I need this to be negative, so both numbers would have to be negative to multiply to make negative 15. So when I look at, do they add up? 15 and negative 1 will not add up to a negative 8, but these will. So minus 5, minus 3, doesn't matter what order I put them in, but that's our solution for that one. If we were to take this, here's how you check it. X minus 5, x minus 3. I take these, I pop them in here, and that's how you can check it. It is okay if you still need to use this to check your answers for it. I would do that, and then I would check. This is negative 8x. Boom, 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 boom. They all match up. Okay, this one, 2x squared minus 5x plus 3. Now this has a 2 in front, but these aren't divisible by 2. So I can't like pull that 2 out, but I can take this 2x and say, well, it's probably going to be a 2x times an x. That's what I would get a 2x squared from. Now, this one's a little tricky, so I am going to use a table here, a 2x times an x, and I need two numbers that multiply to make 3. Honestly, it's either going to be a 3 or a 1, but I need it to add up to a negative 5x. So we got our 2x squared, our positive 3, that's what we had here. Okay, so, all right, looking, to get a 3, we can only multiply a 3 times a 1. 3 times a 1. But since this is negative 5 and this is positive, we do have two negatives multiplied together. So here's the thing. Either negative 1 goes here or negative 3. It does matter. I need to build up to a negative 5. So if I put the negative 3 here, I will get negative 3x. If I put the negative 1 here, I don't get 1 here. I get negative 1 times 2. I get negative 2x, and that does add up to negative 5. That works. Okay, so what is our solution? Our solution, when we factor it, these are the factors to this, would be a 2x minus 3 and an x minus 1. These have to be in this order. You can take this and write it first, and this and write it second, but these two numbers have to be paired, and these have to be paired. Okay, looking at this one, 3, 11, and 6. And 11 is not divisible by 3, so I can't pull anything out. But again, I gotta kind of, all right, 3x squared, a positive 11x, and a positive 6. When I look at this, okay, well, it's probably going to be a 3x and an x to make 3x squared. And to get a 6, it could be a 6 times a 1, okay, a 6 and a 1. Let me play around with that. So if I put a 6 here and a 1 here, I'd get 6, and I would get 1 times 3, I would get 9. 6, 7, not 9, I would get a 3 here. 1. So if I put a 1 here and a 6 here, I'd get 6, and I would get 1 times 3, which is 3. I add them together, I get 9. That combination isn't going to work, so I'm going to work with 2 and 3. Here's the thing, is that I should switch those numbers. If I put the 6 here and the 1 here, and do 1 times that, that would be x, but 3 times 6 is 18. That's too high. We need 11. So I know that the other combination won't work. Now I need the 2 and the 3. So it doesn't matter. I take a pencil and I say, hey, what if the 2's here? What if the 3's here? Well, 3 times 3 would make 9. And 2 times x would make 2x. That is the combination. I can lock it in pen. The reason I did it in pencil is because if this didn't add up to 11, 9 plus 2 does make 11, but if it didn't, I would want to switch these numbers, put the 3 here and the 2 there. But I found our combination, x plus 3, 3x plus 2. X plus 3, 3x plus 2 is our solution for that one. Okay, last one. This one looks ugly, but here, to get an x squared, we would have an x times an x. To get a y squared, we would have a y times a y. And to get an xy, well, that's just multiplying x's and y's. Just focus on this 6. How do we multiply to get a 6? Well, a 6 times a 1, but that doesn't add up to 5, all right? But a 2 times a 3, a 2 and a 3, those would multiply to make 6, and they would add together to make 5. That's our solution for this one. If you don't believe me, you set up a table and you write it out as x plus 2y, x 2y, x 3y, and you go ahead and do x times x is x squared. 2y times x is 2xy. X times 3y is 3xy. 2 times 3 is 6, y times y is y squared, and when we add these together, we get 5x. That checks out because that's what we're, or 5xy's, 5xy. That checks out because that's what we're shooting for. Hey folks, that's a 12-minute video. That's going over the learning targets for this one. Is can you start to factor out some that have numbers in unexpected places like this? All right, take care.